Hello everyone, this is Dr. Lennon, and we're going to take a look at the distance optimization problem on MindTap for Chapter 13. So basically what we've got here is we've got 5 different workstations located in a position on some shop floor, and we've got some workstations that they're all going to make use of. Basically what we're looking for is a way to ideally place this. And not only do they all use it, we're not even going to assume that they use it equally. We've got some demand coefficient factor that we're going to factor into this. So one of the main things that we're going to use is we're going to use the distance formula from algebra. So if you recall that, that's the square root of x minus x1 squared plus y minus y1 squared, and then take the square root of that. Really, it's just the Pythagorean theorem in disguise. So the first thing is to select the function that we want to minimize. And notice we have the Euclidean coordinates of each point, 1, 4, 1, 2, 2.52, 3, 5, and 4, 4. So we're looking for the demand times each of the distances. So the first one, for instance, should be 12 times the square root of x minus 1 squared plus y minus 4 squared. So immediately looking at the options, we can throw out options 4 and 2 because they have pluses in the middle. So now it comes down to choosing between 1 and 3, and we want to actually add all the weight factors and minimize those. So because you have some subtractions in 1, we can see that that's not the correct answer. So I can check the work just to show you that that one's right. And then for the minimization problem, what we want to do is we want to implement this function into Excel. So and then use the solver as usual. So I've done that here. This first set, fabrication, paint, sub 1, sub 2, and assembly, this is just copied from the chart on the actual table from MindTap. And then I've created an XY dummy variable for the ideal position of our tool station that they'll all be making use of. So initially what you do, you just put dummy values like 1 and 1. And then what I did was I created the square of the distance just so it's a little bit easier to punch that formula in. And then distance, you just take the square root of column E, and then the weighted distance, we just multiply the weight factor times the column F value. So as you can see, I've done that. So here's the formulas. So I do B1 minus B7 squared plus B2 minus C7 squared. And always remember, when you're going to use these dummy variable things and you plan on filling down like I did here, because it's unnecessary to retype this formula 5 different times, we want to work smarter, not harder. So what we do is we put the dollar signs around the B1 and B2, and it's going to tell the formula that these two values are going to remain static even when we fill down. So I've created the square of the distance. Then for the actual distance, I just take the square root of the adjacent column, and then the weighted distance, I just multiply the weight by the column there. And then I took the sum of the distances, but really what we care about is this sum of G7 through G11. This is the sum of the weighted distances. This is what we want to minimize. So what we do is we just go to the data ribbon, select solver, and we want to set the objective, this G14, and we want to minimize it by changing these variable cells. The one thing I will tell you is there's nothing in the problem that says that on MindTap, for instance, that in this picture, that these are like walls of the building or the work floor. So for that reason, I chose to make the allow the unconstrained variables to be negative. So where did the Excel tab go? Okay, so here we go. So I unchecked this box because I thought maybe it's okay for the variables to be negative. It would just indicate a position left of the y-axis or below the x-axis. So then I click solve, and it finds a solution. All constraints and optimality conditions satisfied. So there we have it. And, you know, we can enter those values and see that we get the correct answer. So hopefully that helps with the distance problem. And again, trying to enter that complicated formula is not the best idea. It's a little bit easier just to enter it part by part and then and sum the total.